All right, so when you solve this one, it's supposed to be a z dash, right? You get z greater than or equal to -5, I like it, and z less than 8. So this one, I mean, the and, unless it's something extreme, you can pretty much tell. So greater than or equal to -5, it's got to be greater than or equal to -5, right? Yeah. And it's got to be less than 8. It's going to be less than 8. It's got to do both things. So, of course, what's the answer going to be? It's going to be, what's going to go here? Parentheses, I like it. Because it's 8 in both. It's 8 in both. No. That's why it's parentheses, not in this one. That's what that means. Parentheses means I don't include that answer. But is 5 in the -5 in both?
Yes.
Hell yeah. -5's in both. So then in interval notation, it's -5 to 8. It's pretty much exactly what it is on the number line. It's awesome. That's why we left the circles in the dust, because this is a lot more useful. What if I said this? What if you worked a problem out and you get x greater than 3 and x less than -4? Can somebody tell me a number? Give me any number that does both of those things. It's got to be bigger than 3, and it's got to be less than -4. Is there a number that does both of those? No. So if you get this as an answer, it doesn't mean you made a mistake necessarily. What's the solution? No solution. There is no number that's both positive and negative. It's both bigger than 3 and less than -4. You guys see that? Maybe. And if you graph it, yeah, you're like, okay. It's got to be bigger than 3. Got to be bigger than 3. And less than -4, right? So where do those overlap? Nowhere. No solution. If it would have been an or, this would have effectively been my answer, because it would take wherever somebody's got an answer, it'll take it. And they have to both agree. And these don't agree anywhere. They don't overlap anywhere. They don't intersect anywhere. Okay, maybe that's I can't read you guys. If you're like bored, you're like, oh God, he's still saying the same thing, but your face is like, okay, I don't know.
I have a question.
Yes.
For that problem, you didn't flip the signs because you weren't dividing by negative.
Exactly. There is a negative in the problem, but it didn't divide by negative at any point. It didn't multiply or divide by negative.
So it's only when
Only when if this would have been -2, then I would have had to flip it because I have to divide by a negative number.
Okay.
Yeah, I like it. Not just because there's a negative in there, but you have to divide by negative or multiply by negative. Yeah, I like it. Okay. And then one last thing in this section. And this is where you realize, what's the basic, when you solve an equation, what's the main rule? Whatever you do to...
One side, you the other.
Yeah, exactly. We say it that way because there's only two sides to an equation, but however many sides your problem has, whatever you do to one side, you have to do all the other sides. And you're all like, what the shit? How many sides? You're going to have some freaking dice problem with equations? No. So I'm almost certain some of you guys know where I'm going with this. The one thing we definitely have that has more than one side to it would be something like this. 4 less than or equal to 2x minus 10, which is less than 26. There are how many sides to this? 3. There's a left side, a right side, and an inside. Right. So what you do is what do you always focus on when you're solving anything? You're trying to get your variable by itself. So that's where your variable is. So what are you going to do first? See, you don't give a shit about the other sides. You care about making your x uncovered. But the minute you figure out what to do to make that happen, you do that to everybody. Sometimes people just forget about one side, or they subtract 4. I love this part. They subtract 4 and then this disappears. No. If you subtract 4, this is 0. It's still there. I know 0 could be an asshole sometimes, but at the same time, he's a number. He or she, I don't know. I think it's gender neutral. It's like it's everything. All right, so then you add 10 to everybody. And then, of course, you
Divide by two.
divide by 2 to everybody. I don't know. Can you guys see how this is a form of and? This is a hidden and. X has to be less than 18. And, let me see if you guys can read this correctly. X has to be greater or equal to to 7. So this is a hidden and, but you can really see that this is a sandwich. Now, I'm still going to try to get you. So you got sandwiches, but we have a really good sandwich is a sandwich. And of course, this is a math sandwich, so for me, this is a really good sandwich. This is a sandwich. So when you graph this, please let this be stupid easy. Where are all the answers? They're between 7 and 18, right? What do you put on the 7? Bracket, because it's allowed to equal. What do you put on the 18? Parenthesis. Please, dear God, unless you need to, because you have something that tells you have to put the 6, there's no need for that shit, right? I know you know how to count. So put 7, put 18, right? Make sure they're on the right side of each other, and then shade the inside so I know you know what you're doing. There's your jelly in the middle, or whatever you like in your sandwich. If you don't like sandwiches, I'm sorry. This is like, I don't like math or sandwiches, and you just combine the two. Kind of an evil person. The math teacher, evil, yeah.
With the sandwich, you're going to want the variable always in the middle, correct? So
Yeah,
whenever
there.
they give you an equation, it's not going to be like that.
Not in this class.
Oh, okay.
There are possibilities having variables everywhere, but
Sure.
but if you start to think about it, you can realize how it would get really, really weird, very, very quickly. So we're only going to see triple-sided things with the variable on the inside.
Okay. Cool.
Okay. If it starts off with 3 sides, you better end with 3 sides. It's going to just make sure so that you don't do the -4 and go, oh, I got rid of that. Yay. No, you didn't. And of course, I mean, you could put interval notation, right? Blah. Yes.
And then if you solve it down, let's say there was a question and you solved it down, what if it wasn't like, what if it didn't match up to where you could just shade the middle of it like that? Would it ever be like a no solution? So would you ever get values to where you wouldn't be able to make that sandwich?
I mean, it's possible. If I would have reversed these,
Sure.
you could tell from the beginning it was shit. Let me just show you. So if I put, 7 less than, it almost doesn't matter, less than 2, how do I know it's shit already?
It's not.
And I'm saying that 7 is less than something which is less than 2. So how is that possible? How can 7 be smaller than something that itself is smaller than 2? How is that possible? That's the only way that this kind of problem could come out with no answer, and it would almost be silly to do
In the
that.
beginning, you would
Yeah.
see it. Cool.
Now, the mistake people make is, what if I have this kind of problem? Let me just cut to the chase on this. What if I have 5 less than -x less than 6?
You gotta switch those signs.
Yeah, if you divide by -1, people forget to do that, so you get this kind of thing, and that's not possible.
Right.
Is -5 smaller than -6? No. It's bigger. So the mistake was they forgot to, like you said, flip the sign so that it would actually be physically possible. But I have people that just keep soldiering on, they put -5, -6. And this just now hurt me to do this. It should at least give you a little bit of a, right?
Yeah.
This is not right.
Right.
Okay. It's like saying I'm going to the store. That should hurt you if you wrote that. I'm going to the store. You're what? Right? All the different twos. I'm bringing English into this, but still. Right. Okay, I'll stop. All right. You got English in my math class. You got math class in my English. Okay. Why don't we? You want to take a break? No.
Yes.
Yes. Okay. That's what I thought. Let's see. What time is it really? Let's just stop.